Hey everybody, welcome back. Today we're going to be trying out question 8 on the fall 2021 midterm exam. And so the style of this question is a single cycle processor design. So the idea is we're going to get a new type of instruction that we're going to want to implement. And so we're going to have to modify the architecture of our single cycle processor to support this type of instruction. So this question is asking us to add a instruction called FC or function call. And the reason this is useful is it assigns register A to PC plus 1. And then it says that the PC is going to be now at an immediate value, right? So this is useful because I could have a label at a particular function or a value located at a label for a particular function, and then I can jump straight to that particular line and save my old PC or the incremented PC in register A. So it's actually somewhat similar to a Joller instruction, but we're going to go ahead and get started. So it says that we can modify the LC2K single cycle data path. And what we're allowed to do is modify up to 3 of the muxes. Awesome. So the first part of this question is kind of asking us what we need to do or what muxes we need to modify in order to support this architecture. So the way I like to go about these questions is kind of just look at the pseudocode for what each of these operations specify and then kind of modify it accordingly. So the first thing that I notice in this first part here is that we're going to need to assign something to a register to register A. So we're going to have to write to a register. And so when we look at our architecture, that tells me that I need to be able to, so this mux2 right here is in charge of selecting the destination register when we write to data in. And so currently the instruction bits that mux2 accepts is just the bits correlating to register C if I have an instruction that has a third register or a destination register, as well as register B. But currently there's no way to specify that register A is a destination register, right? And the reason for that is that none of our old instructions, our add instructions or our NOR instructions or load instructions, none of those required that register A would be a destination. And so the first thing what I noticed that we're going to have to do is we're going to have to, I guess I'll do this in red. We're going to have to add a line for bits 21 through 19. So those are, remember, those are going to be those correlating to register A into mux2. And so that'll allow us to set register A as a destination. So we're going to go ahead and say that the mux that we're extending is 2, and the input wires that we're connecting is going to be reg A. Right? Or if, I guess, an alternative way to represent it would probably be just the bits. If I remember correctly, I think back when we did this exam, we accepted both. But awesome. So now that we can specify register A as a destination, we also need to be able to write PC plus 1. So our current architecture, fortunately, already calculates PC plus 1, right? Because it takes our PC here and it adds it in the second ALU and it calculates PC plus 1. So that needs to be a potential input for the value that I write into data in. So the mux that decides what value is written into data in is mux3 right here. And so we'd probably want to connect this wire, PC plus 1, as an additional input into mux3. And so what that allows us to do is, specify this value that we're setting register A to. So the mux that we're going to change is mux3, and the wire that we're going to add into it is PC plus 1, right? Or if we labeled this like ALU2, then we could also specify that it's the PCALU that's going to be added as an input. So now we can perform this first instruction within my ISA, but I also need to be able to set PC to a particular place in memory, right? So the place where the PC that decides what I write to PC, right, or the mux that decides what I write to PC is mux1 right here. So what I need to know is that I need to have an additional input into mux1, which will get the memory at an immediate output, right? And so the output from data mem, right? I know the only place I can read from memory, from data memory, is going to be right here. And so sorry, I brain farted a little bit. So what we need to be able to do is we need to take this wire, and it needs to be an input into mux1. And so we can go ahead and do that. So this is going to be mux1, and we're going to have data mem as an output. However, the one part that we didn't really consider is how do I get mem at an immediate value, right? And so what determines the address, right, that we are going to look at in data memory is determined by the ALU. So one of the inputs, or the output that we want coming from this ALU, is going to be address. Currently, we can't do that because it's always going to take the value that's in reg A and try to add it to something. But we don't really care what the value that's in reg A is. So what comes to mind is two solutions, right? So one solution is that, our current offset is going to be, our offset's already here. So offset, or the M value, is already going to be, if we specify that this mux is selected to 0, right? We already have that this is M. So one way we could do it is we could add 0 to the immediate value. And so, the way we could do that is we could add a new mux here. And this new mux, we're going to call this mux 5, right? This new mux takes either register A so that we can support our old architecture, but also the value 0, right? So if it was this type of instruction, we would choose the 0 in that mux. And so essentially we would calculate M plus 0, which would give us the resulting value M. So that's one way that comes to mind. However, I do have another idea. So we would have the input to that new mux would be, one would be val A, right? Because we need to support the old architecture. And the second input could be 0. And the output would be the input to the ALU. So screen. Awesome. However, that's one way of doing it. The other way you could do this, and I'm only going to briefly explain it, is instead of using the ALU at all, right, you could insert a mux right here. It's kind of hard to showcase because it's such a slim wire, but I could have a mux here, And it would either take the output of the ALU, or it could take just the immediate value straight from that line. And that way we'd kind of disregard the output of the ALU, and no matter what, just use N. So those are two options. I can go ahead and actually, yeah, sure. I would take my offset, or my sign extended offset, as one argument. And as the other argument, I would have the normal, the ALU result. And the output of that would be an input into the data memory address. But yeah, so now we've modified our architecture to support this new instruction. The next part is asking us what the control signals for each of the muxes is going to be. So we can go take a look. What it says is that any new or modified muxes, their inputs are going to be 1, 0, no matter what. So we know we modified muxes 1, 2, and 3, and so we can go ahead and fill those in. Okay. So the first bit that we need to kind of make a decision on is PC enabled. Do we want to allow running back to the PC? And this is probably going to be true. Because we want, the only case where we really don't want to update our PC is when we hit like a halt instruction, right? And so we would probably want this to be enabled. Next, we have mux4. So mux4 is going to be this one right here. And so let's assume for this question, we are going with our original solution for mux5. So we're going to have our mux5 inserted. Go ahead and move that. We're going to have our mux5 sitting right here. And its inputs are going to be register A and 0. Did not do that. Oh, yikes. I don't know what I had circled. It's probably something like this. Okay, so we're going to go with this solution. And so in which case we need to choose the offset, right, as the input to the ALU. So we want that value there. So we want a 0 as the input for mux4, because that'll give us the offset on one side. For mux5, right, we want to select the 0. And so if we look at our answer, the 0 is at input 1, and so our mux is going to be set to 1. I think probably if you had like switched these on your solution, like you had 0 and then valet, then your solution, your answer to this part would have been 0. Okay, so now we've decided our muxes. Does reg enable need to be true? So that's probably, reg enable is this right enable bit right here. And because we will be modifying, we're going to be wanting to set reg A to something. We want to set it equal to PC plus 1. This should be enabled because we need to write back to a register. With our current solution, right, which is our muxes before our ALU, we do need the output from our ALU, and we want it to perform an add instruction, right? So we'd put a 0 right there. Now that so that'll calculate the immediate value. And so the last two values is, do we need to enable memory? Well, because we need to perform a memory read in this instruction, this should be enabled. And then, so this is enabled. And then do we need to perform, the last bit is going to tell us whether we need to perform a read or a write. And because we want to perform a read, this is going to be set to 0. If I'd gone with this other solution here, if I'd gone with this solution in blue, what's going to change is that we don't really care what we choose from MUX4 because we never use our ALU's output. Our MUX5 is going to, again, be the same in the sense that if I'd switched these two, it'll determine what MUX5 is, but we want to choose the offset. So under my current answer, it would be 0. And then we don't really care what the ALU's output is going to be, and so it's going to be a 0 under that solution. Awesome. So that's number 8B, and that's the entirety of question 8. So congratulations on making it through this question. Next time, I'm going to take a look at question 9, which is a very similar question, except in fact, it's going to be using the same function, except we're going to be doing it in a multi-cycle design. So I guess I'll see you next time.